joining us to review an important work called The Mysteries of the Sacred Universe, the Cosmology of the Bhagavata Purana, is Dr. Richard L. Thompson. He wrote it. That's why he's joining us. He first joined us 6 years ago to review his landmark publication, Alien Identities. Richard L. Thompson was born in Binghamton, New York in 1947, and in 1974 he received his Ph.D. in mathematics from Cornell University, where he specialized in probability theory and statistical mechanics. I can see him now running around in his mechanics uniform. Dr. Thompson has done scientific research in quantum physics, mathematical biology, and remote sensing. He has extensively investigated ancient Indian astronomy, cosmology, and spirituality, and has developed multimedia expositions on these topics. He is the author of 6 books on subjects ranging from consciousness to archaeology and ancient astronomy. Welcome back to 21st Century Radio, Richard L. Thompson.
Well, hello. I'm glad to be back.
Well, I'm glad you're back, too. What does L stand for, Richard?
Leslie.
Leslie. Well, your book, Richard, is dedicated to His Divine Grace, and I hope if I mispronounce this, my apologies, okay? Swami Prabhupada. That's right, Swami
Prabhupada, yeah.
Yeah. Who was this great spiritual teacher, and what was his mission while in his physical body?
Well, Swami Prabhupada, A.C. Bhaktivedanta Swami Prabhupada, was a spiritual teacher in the line of it's called Gaudiya Vaishnava school of theology in India. And basically, this is a monotheistic philosophy involving yoga, and the ultimate goal is the realization of love of God. So he, when he was a very elderly man, came to America and taught this philosophy and practice, and that was the founding of what is called the Hare Krishna movement.
Mm-hmm. Now, what's the relationship between your publisher, Govardhan Hill,
mm-hmm.
and His Divine Grace Swami Prabhupada?
Govardhan Hill is a company that I formed in order to publish various books along the lines of the book that we're discussing tonight.
Mm-hmm.
So basically, that's my publishing company.
Well, the cosmology of the sacred universe is found in the Bhagavata Purana. Am I pronouncing this correctly?
If not, I can... It's easiest to drop the A at the end.
Oh.
Because you can either pronounce it or not, but Bhagavat Purana.
Bhagavat Purana.
Would be the easiest.
Tell us what the Bhagavat Purana is, who created it, and when. There's a short question for you there, Richard.
Well, the Bhagavat Purana, you see, in India there are a number of sacred texts, and one whole group of these are the Puranas. Now, in the old days, in India and in other parts of the world as well, religion and the general order of society was one unit, basically. Everything was integrated together. So the Puranas are basically books containing history, philosophical teachings, religious ideas, and in many cases cosmology, ancient history, and so forth. So the Bhagavat Purana is one of 18 Maha-Puranas. These are called Great Puranas. There's a number of lesser works also that are also called Puranas. So the Bhagavatam is one of these. And as far as the date is concerned, according to modern scholarship, well, there's a wide range of dates. A lot of people prefer around 1000 AD, which would mean it's about 1,000 years old.
Mm-hmm.
And other dates go back maybe to 2,000 years old. The traditional date goes even further. The traditional date for this work is about 3,100 BC. So there's a bit of a conflict between the tradition and the modern scholarly assessment.
Mm-hmm. Well, that's around the time period of the beginning of the Kali Yuga?
Yes,
Kali
in
Yuga?
fact, that is the beginning of the Kali Yuga.
Yeah, 3102, I do believe.
Yeah.
If I remember correctly from your work.
Right.
Because we want to touch on that a little later on. I learned so much from your work, Richard. I really did. It's a lot. It's amazing how much one forgets in years. But I guess when you start reading 300 to 400 books a year, reviewing them, you really get kind of deluged with the loss of material from one side of your brain. Now, how is the study of Hindu astronomy at a disadvantage in comparison to, say, the situation in ancient Egypt or Mesopotamia or Mesoamerica?
At a disadvantage?
Yes. From the standpoint of the materials that they wrote on, etc.
Oh, well, yes, there is a disadvantage in some respects. In India, the medium of writing that was used was palm leaves.
Mm-hmm.
And palm leaves, if they're kept carefully, may last maybe, I guess, even 4 centuries or so before they finally deteriorate,
mm-hmm.
but no longer than that.
Yes.
Whereas, for example, if you go to the Babylonians, they wrote on clay tablets that they baked, so that they were practically indestructible as long as they weren't physically broken up. Likewise, in Egypt, you have inscriptions in stone. So it is a fact that in India, there's a problem of preservation of really ancient material. One has to depend on a living tradition to keep the knowledge going on.
Well, when we return, well, that is quite a disadvantage. I mean, I had forgotten that, Richard, because if you only got palm leaves that are going to last for 400 years, then other historians coming from outside the field are really going to have a difficult time verifying what you're saying and not saying. And
yes.
That can cause all kinds of problems. I mean, you mentioned the dates 1000 AD, 2000 AD, 3100 BC, and then there would be some that would say it's just centuries. I mean, like something like about 200 or 300 AD, BC, somewhere around there. There's a great variation, and it would make it really very difficult area to study.
Well, in general, in India, it's difficult to assign dates to texts.
Mm-hmm.
This is a general problem. And a lot of the dates that are assigned are somewhat speculative. It's based on the style of the writing as compared to the style of other writing that has been dated, and so forth. So it's a bit difficult to arrive at dates.
Well, when we return, we're going to ask you this question. For centuries, at least, the Bhagavad Puran provided a meaningful framework connecting the world of the observable phenomena with the transcendental world of ultimate reality. And it describes innumerable universes. I'm going to ask you to please review the description of what is inside of each spherical shell that contains a universe. And if you can answer that correctly, you'll win a free trip to Bermuda.
Okay.
We'll be back with our guest. Boy, friends, I really learned a lot from this book. And there are so many illustrations. There's also a CD. There's a video, but I haven't seen the video. But when you watch these images, and of course being an artist, that's how I would learn. And I was able to watch some of the movies within the CD-ROM. And I really learned a great deal from that experience. Our guest is Dr. Richard Thompson. Mysteries of the Sacred Universe. Govardhan Hill Publishing, www.sacreduniverse.com. To order, call 904-462-0466. Now, Richard, for centuries at least, the Bhagavad Puran provided a meaningful framework connecting the world of the observable phenomena with the transcendental world of ultimate reality, and it describes innumerable universes. Would you please review the description of what is inside of each spherical shell that contains a universe? And friends, listen carefully. I learned so much from this particular area that this is one of the areas I enjoyed so much.
Okay, well, briefly, the basic universe, as described in the Bhagavatam and the different Puranas, is, as you mentioned, a sphere. And the name for it in Sanskrit is Brahmanda, and that means Brahma egg. Maybe you've heard of the cosmic egg?
Yes,
well,
sir.
This is where that term comes from. So you can imagine a spherical egg. So it's described that there are innumerable universes, or Brahmandas, floating in what is called the causal ocean. So they're compared to bubbles of foam in the ocean. So you can imagine a vast extent of water with innumerable little bubbles of foam in it. This causal ocean is part of the larger spiritual world, just to put it all in perspective. Now, each of these little bubbles or spheres contains a series of spherical shells which are made of primordial elements. And in the center, within this nest of shells, there's 7 or 8 of them, depending on the description. You find the actual area where the sun, the planets, and so forth actually exist. So within each shell, what is being described is basically the solar system. So within the shell, there is a disk that cuts across that spherical shell. And this is described in geographical terms. So the first impression that you would get about it is that what you have here is a flat Earth, an Earth disk. But it's a little bit unusual because instead of just coming to an edge where you could fall off, as they say, from the edge of the flat Earth, this disk extends right out to the spherical shell. So that disk, I'll call that generally the Earth disk. But an important point to understand about it is that does not actually refer to a flat Earth in the naive sense. Actually, it refers to the plane of the solar system. So in the center of this disk is the Earth, where we are. It's a geocentric system. And surrounding it, there's a series of rings on this flat plane. And as I guess we'll get to mention in the course of the discussion, these rings correspond to planetary orbits. So that's a basic synopsis.
This is this model then not only describes the universe then, but our solar system and our planet's geography.
Yes, one interesting thing about the way this ancient text is written, and I think you'll find that's true of a lot of ancient works as well, is that one model, like what I just described, is given several different meanings. The text is deliberately built in that way. I gave an example of this just to illustrate the idea by referring to old paintings. For example, you could have a Renaissance painting showing a story from the Bible. And in that painting, you'll see St. Peter in 4 different places on the same painting. So basically what the artist has done is he has told 4 different parts of the same story in one painting.
Mm-hmm.
So it's a similar thing, and you see this in Indian art too. It seems to have been a general practice in various traditional societies to do things this way.
Certainly in Egypt and certainly in Central America.
Yeah.
So that in a certain sense, it's kind of like those of who are artists, kind of like Cubism in a way, except that the forms are painted. You can recognize them, but you have many different perspectives going on at the same time.
Yes, this is actually how the transcendental element is combined with the physical element,
mm-hmm.
by the way. For example, this disk that I told you about, the Earth disk we can call it, on the one hand, this refers to the solar system. And in the text, there's a whole series of different points in which you can see clearly that it's referring to the solar system. At the same time, it refers to the Earth globe. And there's a whole series of points with that meaning. In addition, there's yet another meaning in which it's referring to the celestial domain of reality. And then finally, yet another meaning that it has is it refers to a topographical map of an area of southern Asia, which includes India. And this is probably the original culture area of the people associated with writing this text.
Mm-hmm.
It's not just India, but it's a broad area including Tibet and parts of China and Siberia, Kazakhstan. That general area is the original culture area that we're talking about here. And so one of the meanings of this structure within the Brahmanda is it's a map of that region. Now, there are several different meanings to the same structure.
So there are multiple level of meanings, and much of this is expressed in mythological language. I want to return to that in just a second, but I want to remind our audience of this. Friends, remember when David Ovison joined us, and we discussed, and he'll return in April, he's coming to America, the language of the birds, the language of the green language. These languages are multi-leveled, many meanings. And this is key in understanding the ageless wisdom teachings throughout all of the ancient cultures. Every symbol, every myth has multiple levels. And it's very difficult for those who adhere to just one level to absorb what is being related. Excuse me, Richard, I wanted to mention that and draw that link to one of our other guests who is examining the Celtic tradition in that regard. Now, much of this, as I noted, is expressed in mythological language. Why? What are the advantages of using mythology rather than other means, other rational, reasoned means?
Well, basically, the one advantage to using mythology to present the picture is that it easily can be retained in people's minds. We mentioned the whole problem of transmitting these texts, the fact that the written materials were perishable, and you have a very hot, humid climate in India, for example, which isn't so conducive to preserving things. So one aspect of these texts is that they are presented in what is called mythological language. So, for example, in this case, the solar system, which is also this Earth globe map and so forth, as I mentioned, it's described in geographical terms. So the description is written in terms of islands, oceans, and mountains. So it's a very colorful and vivid description.
Indeed, yes. When we return from our second break, you refer to the knowledge filter, and we've discussed this previously with you years ago. The knowledge filter is utilized by academia and, in my opinion, the media, the government, and in short, the establishment to prevent unwanted information from leaking into the mainstream thought. When we return, I'd like to discuss what a knowledge filter is, how successful it's been in keeping information kind of, lost, in quotes. And I was just so overjoyed to see some of the names that I studied so many years ago. I think you pronounce his name Stachini, Schwaller de Lubix, de Santillana, Talana, and von Decken. Now, friends, you can see I mispronounced most of them, and this is because I was book-learned. I didn't have a teacher. I just used to read this material, so if I mispronounce it, my apologies. And excuse me for that too, Richard, but that's one of the problems from learning from reading.
Yeah, well, we all have that.
Well, we'll return with this particular on this particular question, so you can brush up on it, will you please? We'll be right back with our guest, Dr. Richard Thompson, when we talk about the knowledge filter here on 21st Century Radio. The book is Mysteries of the Sacred Universe, Govardhan Hill Publishing, www.sacreduniverse.com. So, the knowledge filter. I've already... how does the knowledge filter make certain information lost?
Well, this knowledge filter is basically a function of human nature. When people gather together and they arrive at a certain consensus, they tend to judge incoming information based on whether it agrees with the consensus or not. And there's a tendency to reject things that don't agree with the consensus, or at least to make them jump over a higher hurdle than other things which do agree with the consensus. So you have, for example, the phrase that extraordinary claims require extraordinary proof, which is often said.
Mm-hmm.
But whether a claim is extraordinary or not depends on what your accepted viewpoint is. So if you have one viewpoint, a given claim may seem to be extraordinary, and then you'll require extraordinary proof in order to accept it. In another case, if you have a different point of view, the claim may be quite ordinary, so then you'll accept it on the basis of ordinary proof. So this is a natural human tendency. So we always, and of course, to form a consensus is a natural human tendency also, and a very important thing, because if we couldn't form any consensus, then we'd all be completely at odds with one another. So the knowledge filter is sort of a basic problem that emerges from these aspects of human nature. But we have to recognize that a lot of valid information does get filtered out from various accepted worldviews.
Well, when we get to measurements, I was so fond of the work of Livio Stachini, and I'll never... Is that how you pronounce his name?
Well, it's how I pronounce it.
Yeah. I mean, I wish I would have... I never interviewed him, never talked to him. I don't even know if he's still alive or whatever. No. But I believe it was some work in 1971 or 2. Maybe it was Peter Tompkins, but it probably was other researchers mentioning his work in the Great Pyramid and discussion on his work on the Great Pyramid, which I think could have been more accurate, but that's the way life is. And also the work of especially Schwaller de Lubix. Could you use Schwaller de Lubix as an example of his work being his information that he was proposing was filtered out?
Well, yes. Basically, Schwaller de Lubix was studying ancient Egyptian monuments. And among other important conclusions, he came to the conclusion that these monuments reflected a higher level of scientific knowledge than we would expect for ancient people who supposedly were in a more or less childhood stage of civilization. I have a quote here, maybe I could read for you, that gives you the standard viewpoint.
Mm-hmm.
This is by a very important scholar named Otto Neugebauer.
Oh, yes.
Who was at Brown University. He's deceased. But he said, it is a serious mistake to try to invest Egyptian mathematical or astronomical documents with the false glory of scientific achievements, or to assume a still unknown science, secret or lost, not reflected in the extant texts. So that's more or less the standard viewpoint.
Mm-hmm.
If you want to propose information that goes against that, you do indeed have some very serious hurdles to get over. And Schwaller de Lubitsch is in fact presenting such information. And I'll give you, shall I outline basically some of...
I think his work is so important and so little understood, and we do have a number of individuals from Johns Hopkins University that are listening, and I've discussed some of these things with their Near Eastern department with various heads, and it's important that this, I think, be mentioned in this area.
Yeah, well, I'll mention then, basically what he did, and this is one amongst quite a number of things that he accomplished, was to observe that the units that were used in building various monumental structures were based on scientific information concerning Earth measurements. So, first of all, how do you deduce a unit from a structure? Well, let's say you're looking at a wall. If you measure the wall and you find that it's measured in multiples of a certain unit, and other walls of the same building are different multiples of the same unit, then you may conclude that, well, this unit was actually being used in laying out that wall, or that building, I should say. So he made a number of deductions of this kind. And, of course, there was knowledge about what some of these units were in terms of their name and their relation to other units used by the Egyptians. So let me give you an example. This has to do with a unit that we call the fathom. Now, the fathom, roughly speaking, can be based on the body, and it's the distance between your outstretched fingertips if you stretch your arms as widely as you can. We tend to use that unit today in nautical contexts. As is true of many of these units, the reference to bodily parts does not refer to the original definition of the unit. It's just a convenient way of referring to the unit. The same is true of the foot. The foot is not actually based on the length of somebody's foot, but it's roughly that length, and it has its own precise definition based on some standard rod, let's say. So what he found was that the fathom is related to subdivisions of a degree of latitude. In fact, if I remember it correctly, let's see.
The measurements are exceedingly important, friends. We're next hour. We'll get to the one particular length of 8.5 miles as a unit of distance called, here we go, Yojana or Yojana.
Yeah.
And that study that you did on the ancient Hindu cosmology, I found fascinating. Let's move on.
Here's the thing I was looking for on the fathom.
Oh, you got that. Okay.
Yeah, I found it. It's at 1,000th of a minute of latitude. So imagine you're going from north to south, and you cover 1 minute of latitude. That's 1/60th of a degree of latitude. So that's the definition.
Mm-hmm.
Now, the interesting thing is, if the Earth were a perfect sphere, the minute of latitude would be the same anywhere as you go from north to south. but it's not a perfect sphere. Actually, the Earth bulges out a bit at the equator. And because of that, the minute of latitude has different values at different latitudes. So there's the minute of latitude at the equator and the minute of latitudes, let's say, at the North Pole, which is a little bit longer. And in between, there's a range of values. Well, what Schwaller de Lubitsch noted, for example, measuring one wall in this temple at Luxor. So you imagine a room which is basically oriented north-south, and the northern wall was 12 fathoms, quite precisely 12 fathoms. The southern wall was also 12 fathoms. But the northern wall was 12 fathoms as measured in terms of 1,000th of a minute of latitude at the North Pole, whereas the southern wall was measured in terms of the fathom, which would be 1,000th of a minute of latitude as measured at the equator. So, and this came out pretty accurately. So what's going on here? Well, you could say, well, it's a coincidence. Schwaller de Lubitsch raised that point. Then he said, well, but we find this over and over again when we measure different monuments. We find that they're using two different values of the fathom. And it seems to be related to the minute of latitude, and it seems to reflect knowledge of the variation in the minute of latitude as you go from the equator up to the North Pole. So he said, so let us acknowledge then a repeating coincidence. In other words, we find this coincidence over and over again. So this is one example of the kind of thing that he observed. So if it's not just a coincidence, then it would seem that the Egyptians understood not only measurement of latitude, which requires at least that they would have to know that the Earth is a globe, but even worse than that, it would imply that they knew about the equatorial bulge of the Earth. And that's an extraordinary statement.
It is, because you can no longer think of these as primitive societies. They have obviously had advanced at least certain aspects of their societies, whether they be a small group within that culture, an elite or an elect or whatever, had obviously more advanced scientific knowledge than we've ever thought. And I think that as we move into the 21st century, that is one of the things that we're going to discover repeatedly.
Yes, well, the interesting thing is, you see, if you just look at this a little bit carelessly, let's say, or taking it at face value, you'll see that there are different values for the length of the fathom.
Mm-hmm.
And so you might say, well, these people weren't very accurate. And this is true of a number of other units also. There's the different cubits that were used by the Egyptians, the royal cubit. All of these units appear in slightly different values or lengths. And the simplest explanation would be, well, these people were careless in making measurements. They were inaccurate. But then when you look more closely, you see that actually they had different contexts in which these different units were used. And in fact, each one is very precisely defined. And you find this underlying relationship with the measurement of latitude. Let me mention another curious thing.
You have about a minute and a half.
Pardon me?
You got about a minute and a half to mention a curious thing.
Okay, this is the meter. Now, the meter is a unit that goes back to about the French Revolution. When it was defined, when they founded the metric system, it was defined initially to be 1/10,000,000th of the meridian quadrant. That's the distance from the equator to the North Pole along a meridian, through Paris, in fact. Well, Schwaller de Lubitsch pointed out that the Egyptians used a length which was almost precisely 1 meter. And again, it was based on measurements of walls. For example, one pylon, the height of it was 25 meters plus or minus 1 centimeter. So once you make a number of measurements like this, you come to the conclusion, well, they're using the meter. But how did they define it? The original definition was in terms of, once again, a subdivision of latitude. So that's another example.
Well, when we return next hour, we'll examine in more detail the thesis that there were ancient civilizations that had a greater grasp of scientific knowledge, and how in the world did they obtain this information is key. We'll be back with our guest, Dr. Richard Thompson, Mysteries of the Sacred Universe. The book that we're touching on tonight, and we're only skipping here and there in this particular work. It's important. It's called The Mysteries of the Sacred Universe. Its author is Dr. Richard Thompson. He's also a Ph.D. And this is published by Govardhan Hill Publishing. You should certainly go up to his website, www.sacreduniverse.com. You can order this book, or in its CD form, or in its, CD-ROM form, and its video form by calling 904-462-0466. We think it's a very important work. I certainly learned a great deal from it, but, you know, there's so many things I need to learn in this incarnation. You know what Professor Gene R. Thursby, Ph.D., University of Florida, happened to say about this important work called Mysteries of the Sacred Universe? He says, overturns a long history of scholarly undervaluation of the supposedly only mythological contents of Puranic literature. Gene Thursby. Hey, I think he's related to, what was it? It wasn't the falcon. Yes, the Maltese falcon. It was Thursby that got, well, we lost him. He died. This is not the same one, but he could be related, you know. And also, Professor Subhash Kak, K.A.K., Ph.D., Louisiana State University, Thompson presents a compelling case showing the Puranic cosmology was intended to have, listen to this carefully, multiple meanings that span the terrestrial, astronomical, and spiritual planes. And of course, the more we learn about all the different lines of ageless wisdom teachings, whether they come from Egypt, Sumeria, or Afghanistan, or what have you, is that there are multiple levels of meaning. So those individuals who espouse a fundamentalist philosophy have a difficult time in accepting the possibility that you could be saying several things at one time and not just one thing at one. Well, you know what I'm saying. Richard, are you still with us?
Yes, I'm right here.
I'm sorry I had to expound there, but I get into that every now and then. And besides, it's my show. I guess I can do it, right?
Yeah, I guess so.
I guess so. We're paying the piper, so I guess we can talk. Now, your study of the ancient Hindu cosmology led to learning the length of 8.5 miles as a unit of distance called, and you pronounce this again, Yojana. Why is this measurement important?
Well, the Bhagavatam, or Bhagavat Purana, contains a rather extensive section on cosmology, and it's quantitative. I mentioned this spherical shell with the Earth disk cutting across it, which is marked by a series of circles, which are referred to by names as oceans, islands, and mountains.
Kind of reminiscent of what Plato's theory of what Atlantis looked like.
Yeah, if you imagine, I guess Atlantis was surrounded by many rings.
Yeah.
Well, this is a similar pattern.
Similar.
And you can imagine that the rings in towards the center are much smaller and than the ones extending out towards the periphery. So these are given measurements in terms of a unit called the yojana. So that's where the yojana comes in.
Well, how is
diameter of each of these rings is given as so and so many yojanas.
Well, how is the yojana connected with units of measurements in the Old Kingdom of Egypt?
Well, that is something that I stumbled upon. And the way this developed is this. Basically, the translation of the Bhagavatam that I was using said the yojana is approximately 8 miles. So I looked into that, and I found that, as is often the case with ancient units, there are different values to the length of the yojana. And I should mention, by the way, there's historical evidence that there used to be different lengths of the mile in England based on old road markers, just to bring it a little closer to home. But there are a number of lengths for the yojana. So, but the text I was using, well, the translation said 8 miles, and 8 miles is certainly one very common length. So I used that, and I made a comparison between the orbits of the planets and the diameters of these different rings. And I found that they seem to match up. So maybe we'll get into that story a bit later, but first I'll explain how this all relates to Egypt. Basically, what I found was that the rings match up pretty well with the orbits if you use 8 miles per yojana, which was the figure I started out with. If you adjust that to 8.5, you find a really good match. And in fact, I thought, well, let me just find a general way of expressing how good the match is and plot that for a whole series of values. And I found that there was a very strong peak or spike of goodness of fit, you might say, at about 8.5 yojanas. So 8.5 miles, I mean to say. So I concluded, well, it seems that in this text, the yojana should be 8.5 miles in length. So I then asked the question, well, is there any historical evidence that a unit of that particular length was ever actually used? And so I investigated what people had written about the yojana, and I discovered that, in fact, there is some historical evidence which can relate the yojana to the Greek stadium. The stadium was a unit of length among the Greeks. And the stadium is also multiple valued, as you find with ancient units. But one particular length of the stadium was again based on division of the degree of latitude. And that says that there are 600 stadia to the degree. And so basically I found, on the basis of some historical documentation in which after Alexander the Great invaded India, there was an ambassador from his successor named Seleucus Nicator. This Greek ambassador was named Megasthenes, and he went to the court of one of the Indian monarchs, believed to be Chandragupta. And so there's reference there to the relative, that is the relationship between the Indian units of measurement and the Greek stadium. And so one can conclude from that there are 40 stadia per yojana. So this was the beginning of a link between the Indian units and the Greek units. So for a while, that's all that I knew, and I didn't take very seriously the point about latitude. I just thought, well, the units seem to match up. But later on, I ran across the work of this Livio Stachini that you mentioned. And that's a very interesting case regarding the whole question of the knowledge filter. If you look in the book, I think it's by Peter Tompkins, Secrets of the Great Pyramid, you'll find an appendix in the back by Livio Stachini. Apart from that appendix, now this Livio Stachini was a scholar. He was I guess his original PhD thesis was in the field of Roman law. Of course, he was from Italy originally. And he eventually became involved with writing about political developments involving the United States in relation to other foreign powers and so forth. But his real interest was in studying ancient units. And he observed two things. One was that the units that we have today are descended from ancient units, and you can pretty much trace out the history of how the units descend with numerical accuracy, which to me was quite surprising. And then the other point was that when you go back to the ancient units, you find that these are based on subdivisions of a degree of latitude.
Uh-huh. Mm-hmm.
So he tied all kinds of different units together. And the story is quite remarkable.
It is. I like the way you related it within this work.
What I did in the book, Mysteries of the Sacred Universe, because once I discovered this, I realized it was an important part of the whole picture. So I did an investigation of Stechini's work. Unfortunately, in that appendix, there are no references. And when I tried to find other writings by him on the same subject, I found a couple of very brief articles that didn't contain much information, and that was it. So, and unfortunately, he is deceased. But I investigated what he claimed, and I found that pretty much it checked out. In the earlier part of this century, there were quite a number of studies of ancient metrology, which is the science of units of weight and measure and length and so forth. So I found that his claims checked out, and they provided a way in which the yojana could be related to the ancient Greek and also ancient Egyptian units. Of course, the Greek units were related to the Egyptian ones also.
So what we're saying here is that somehow the ancient Egyptians, Hindus, and others knew the accurate measurement of a degree of latitude.
This would seem to be the implication.
And, of course, the question would be, where in the world did they learn this if they were so allegedly primitive? Did they learn this all together by coincidence, approximately at the same time? Did they learn this from some particular inspiration within, or was it just cultural diffusion? And we'll need to take a look at some of that when we return with our guest, Richard Thompson, Dr. Richard Thompson, with the book Mysteries of the Sacred Universe. Gavardon Hill Publishing, www.sacreduniverse.com. Phone number 904-462-0466. Available on CD-ROM and video. Our guest this evening is Dr. Richard Thompson, Ph.D. The book is Mysteries of the Sacred Universe. Yes, it's an important work. We've only mentioned it 1,400 times. You better be paying attention and taking notes, because this next week's prizes are going to be taken from this week's questions. It's true. Always has been that way. And to order a copy of this book, go to call 904-462-0466 or go to his website at www.sacreduniverse.com. Well, it seems that Egypt, India, Mesopotamia may have learned the measurement of a degree of latitude, and I don't believe that mainstream science has, I don't think they have an easy time explaining how they came by this knowledge. An important question, obviously, is to ask, how did ancient India and Egypt come to learn and to utilize that knowledge? Was it coincidence? Was it cultural diffusion? Or was it learned from spiritual beings or some ancient other civilization that doesn't exist? What do you think is the probability of this?
Well, first of all, as far as cultural diffusion is concerned, I think it's clear that there was sharing of knowledge between different societies in ancient times. So just to give another example, just to illustrate that point, we have a unit of measurement called the ounce. Actually, we have a couple of different ounces, troy and avoirdupois. You can trace the ounce back to the Roman ounce. This is one of the things that Stachini talks about. It's pretty clear. Our ounces are based on the Roman ounce. Curious thing is, if you go to the Indus Valley civilization, which existed in what is now the area of India and Pakistan, in the archaeological excavations there, they found a series of units that were evidently used for weighing produce in a marketplace. One of these, in fact, is the Roman ounce. That is, it has the same value. That would date back to around 2300 BC, quite a long time before the Roman Empire. Also, by the way, there are modern units still used in India in that general area, which are basically the same as the ones used 23 and 2300 BC, or thereabouts. So here you have an example of one unit of measurement which apparently spread very widely all the way from India to Rome, and then, of course, it survived into modern civilization. So that's just an indication. So there was communication, it's pretty clear, between different societies. Now, the question still comes up, though, of how people knew about this information to begin with. The astronomical correlation that I mentioned between the orbits of the planets and the rings in this Earth disk, that is also quite extraordinary, because how would people have known the dimensions of the planetary orbits? So in terms of modern science and technology, the way we know about those things is basically the same way that we know about distances on the Earth. We make use of telescopes plus the associated mathematics. For example, to measure the orbits of the planets, one makes observations with telescopes, and the ultimate key to getting the distances correct is you have to find the actual distance of, let's say, one planet by trigonometry. For example, the way it was initially done by Cassini back in the late 18th century is you, at a close approach of Mars to the Earth, you triangulate the distance to Mars by measuring the angle to Mars at Paris, and also in French Guiana. So with those two measurements and knowledge of the baseline distance, you can find out how far away Mars is. But to do that, you need an accurate telescope. So likewise, to measure the degree of latitude accurately, you'd need surveying instruments, which are also based on a telescope. So this would be one way that it could have been done. But then, of course, the question is, well, do we have any, first of all, surviving documentation talking about such telescopes? And do we have any physical examples of them? And the answer then, of course, would be no, we don't. So we can't really say how they could have known. Another possibility, of course, is the idea of communication from outside, the ancient astronaut theory. Namely, that the humans themselves were not able to obtain this knowledge at that time, but the knowledge was conveyed to them by some other beings. This is another possibility. It seems to me, judging from the evidence, that what we're dealing with here, though, is very much earthly knowledge. It just that we don't have any surviving evidence of the specific techniques that were used to obtain it. But I do have the impression that it was human earthly knowledge.
The area of cultural diffusion, or information getting from crossing the Atlantic and Pacific, is one of those areas that I think hopefully within the next several years is going to be resolved, mainly because of you can get in a bathtub in France and you can cross the Atlantic Ocean within 6 to 8 weeks without it steering anywhere. It's been done a number of times, and yet we still have serious problems amongst scientific researchers saying that you know, they don't see how people crossed it until somewhere maybe around 300 or 400 years before Columbus. But indications, especially the work of Dr. Robert Schoch, who's joined us repeatedly in his new work coming in the months to come, indicates that that crossing probably took place at least 7,000 years ago and could be as much as 15 to 20-some thousand years ago. Richard, you suggest that an international scientific community existed about 2500 BC that possessed the knowledge that we're talking about and utilized it. You say that, don't you?
Yes.
When we return, we're going to find out what happened, or what perhaps may have happened to that community, and how this knowledge became lost. This is 21st Century Radio with our guest, Dr. Richard Thompson. The book is Mysteries of the Sacred Universe. To order, get a copy, 904-462-0466. We'll be right back. Tonight, our guest is Dr. Richard Thompson, Mysteries of the Sacred Universe, Gavardin Hill Publishing, www.sacreduniverse.com. To order, call 904-462-0466. It's also available in CD-ROM and video. So, one solution to this is a suggestion that you make, that is the solution to the problem of where in the world did the ancients, who were supposed to be so primitive in this area, how in the world were they capable of measuring a degree, accurately measuring a degree on the Earth? You suggest that an international scientific community existed somewhere around 2500 BC that possessed this knowledge and utilized it. What do you think happened to that community of scientists?
Well, one thing to realize about such a scientific community would be that probably the number of people involved would be quite small, and if there was any disruption in the society, the scientific community might be the first thing to go before the basic structure of society was greatly affected.
And that sounds exactly like the Brookings Institute report in regards to UFOs.
Today, of course, we have big science. multi-million-dollar funding for scientific research. But it didn't necessarily have to be that way in the distant past. If you just go back a century or so, you'll find that science was not institutionally as big as it is now. Even, say, in the time of Isaac Newton, it wasn't as massively established. Now, there is evidence showing how knowledge can disappear. And one example, which I think brings this across pretty clearly, is the Greek computing device that was found in a shipwreck. It's called the Antikythera computer. It was found in a shipwreck next to a Greek island with that name, Antikythera. I'm not sure, by the way, how that is pronounced. But anyway, this object, when it was first brought up from the depths of the ocean, was a corroded lump, basically. but by very carefully studying it and using X-rays and so forth, it was found that this was a system of gear wheels which apparently formed an astronomical computing device. The way apparently the device worked was that you would set the time on a main dial, and the positions of the different planets, Mercury, Venus, Mars, Jupiter, and Saturn, in the different signs of the zodiac would be shown in different little windows. So it was a pretty sophisticated device using sophisticated arrangements of shafts and gear wheels and so forth. The interesting thing about it is that this is basically one of a kind. There is no surviving documentation describing the principles for building such things or talking about them, and there are no other physical examples. We just have this one example. And yet it's certainly hard to think that this just stands in isolation, that one person, let's say, got the idea of building this thing, and he built one, and this is it. Most likely, there had to be a gradual development of the technology of the gear wheels and also the science behind the astronomical calculations which the gear wheels embodied. But that's lost. So that shows how scientific and technical knowledge can be lost, because that shipwreck could easily have been missed, and in that case we wouldn't know about this at all.
Well, both you and Michael Cremo created perhaps one of the most important works in the past decade in forbidden archaeology, and then later on an abbreviated form of the hidden history of the human race. And you suggest, of course, provide information that indeed there was a great deal more knowledge lost than we had ever considered before. And I think that was one of the most important, as I noted earlier, your work is one of the most important contributions to laying the foundation of evidence, let's put it that way, all in one place. And so I wanted to suggest that our listeners pay attention to that. If they still have it has been released in paperback form, right? Hidden History of the Human Race?
Yes, Hidden History is in paperback.
Yeah, just an extraordinary work. And the academic community, the method by which they responded to it, I'll never forget Leakey's response to it. I just never thought he would have responded that way. What did he say about that important work?
Oh, let's see. Richard Leakey, yes, he said something to the effect that this is completely worthless and only for fools.
And others were saying this book should be burned. That was extraordinary.
Cornucopia of Dreck was one of the phrases.
And some of us are finding it the most important work within the last decade, and others is just a cornucopia of Dreck. Well, now there are obviously. By the way, do you think these communities of scientists still secretly exist?
Well, if so, I guess the secret is well kept. I should make a comment concerning the idea of secret societies. It is a fact that in old traditional societies, for example, in India, technical knowledge was kept secret. We know this, for example, from a text called the Surya Siddhanta, which is an astronomical text, in which you find the statement that this information is only to be disclosed to a disciple who has been faithfully serving the guru for 1 year. So the idea is the knowledge wasn't simply broadcast freely in all directions, but there was a selection process to decide who would be able to acquire this knowledge. So there was secrecy. Apart from that, when you're dealing with technical knowledge, it is rather difficult for that knowledge to easily propagate, because it requires serious study. And a lot of people don't want to bother with the details of technical knowledge. If there is some secret doctrine, which is kind of fascinating and far out sounding, then easily someone can spread that around. But details of calculations and so forth are not like that. So that's one point. So an ancient scientific community could easily have been wiped out. Now, one thing I do mention in the book is that there is evidence that this ancient civilization may have been affected by a period of dark ages. Now, if you look, for example, in India, the reason I gave the figure 2500 BC as a date for this period of scientific development is that that's the basic date for the Great Pyramid in Egypt. And these various observations I'm making about the units of measurement are reflected in the dimensions of the Great Pyramid. So that's a convenient date. If you go over to the India-Pakistan area, at about that time, the Indus Valley civilization was flourishing. So that was flourishing, let's say, from about 2300 BC down to maybe 1900 BC. But then it died out. And that's quite mysterious. The civilization was characterized by very well laid out streets and buildings and so forth. But apparently, over the course of a few centuries, city life practically died out completely in that whole area. And then later, around maybe 800 BC, it started up again. So the question is, what happened? It's interesting that if you go to the Mediterranean region, at about the same time, there were also dark ages. For example, the Babylonian culture was eclipsed by a dark age. The Greeks had a dark age, and so forth.
You think these dark ages perhaps could be brought on by rocks from space?
Well, it's hard to say. It could be something even less exciting than that. I was recently reading an article arguing that there could have been very extensive drought.
Mm-hmm.
If you have a society based on agriculture and a very severe drought sets in, that can have a very disruptive effect.
Or a rock from space could cause that.
Well, yeah. We don't really know the cause for these climactic effects. We're very much at the mercy of climate.
Now, if we had more time, we could talk about some of the examples around the world in which the cosmological systems are similar, broadly similar to that of the Puranas. I wish we had time to do that, but we don't. But I'd like to go to something that my very first teacher from Johns Hopkins University used to pound in my head, and that was about the Kali Yuga, which the starting date is somewhere around February the 18th. This is pretty specific. February the 18th, 3102 BC. And this is another example when you understand what the Kali Yuga is and how the people arrived at that 3102 BC in the first place. Another example of pointing to advanced astronomy. What was the Kali Yuga?
Well, the Kali Yuga is the age of quarrel and dissension. And that's part of a system of yugas that repeat in a cycle. Since I know we don't have much time, I'll briefly mention the specific date, February 18th, 3102 BC, at midnight on February 18th, at the meridian going through Ujjain in India, so that really pins it down very accurately. At that date, according to tradition, the planets lined up, just like the horses at the start of a race. Very briefly, the story behind that is that, in fact, the planets didn't really line up that closely at that time. But if you look at the, let's say, period from 4000 BC up to 2000 AD, that precise date is one of three dates in which the alignment of planets is as close as it ever comes during that entire period. I'd have to go into detail about how you define close and so forth.
Mm-hmm. Well, we won't have time to go into that kind of detail.
Yeah, but the basic point is that based on modern astronomical calculations, a very close alignment of planets occurs on that particular date. And if you look at this entire 6,000-year period from 4000 BC to 2000 AD, which was the period I looked at with a computer, you'll find that there are only three such dates in the entire period. At all other times, the alignment isn't as close. So somehow that date is picked out very precisely by modern astronomy. But we know that that date was known as far back as 500 AD. And of course, in 500 AD, the astronomy that they had was quite crude. So how could they have known that? That becomes the question.
Mm-hmm. Well,
the implication, as I can see it, is that either, of course, in 500 AD, astronomy was in a pretty crude state. Either at some earlier date they had more advanced astronomy and they calculated that date in the same way that I calculated it, basically, or else that date must have been historically real. That is, people must have observed the alignment when it occurred, and they must have known what they were observing to see that that was significant, which also would require considerable knowledge, because otherwise you wouldn't even know that anything unusual was happening.
Mm-hmm.
And then they must have been able historically to transmit that information down to the present time. So that's also quite remarkable.
Yes, indeed. In the last minute or so that we have left, what indicates that advanced science in ancient times may not have used the same approaches as science does today?
Well, the reason that I have said that is that if you look at the text of the Bhagavatam, the way things are expressed is conceptually somewhat different from what we're accustomed to today. Then again, if you look, say, at the work of Schwaller de Lubitsch, I think you can get a fairly clear idea of this.
Yeah.
Just in the matter of numbers, for example, we take numbers for granted as mere quantities. But it's pretty evident from his work that the numbers that the Egyptians were dealing with were regarded as philosophically meaningful entities. So they had a completely different approach to science than what we're accustomed to. Then again, this gets back to the question of the so-called mythological aspects of the Bhagavatam. I extracted from that description the quantitative data and found that it corresponded to planetary orbits. But then there's also the question of the actual meaning of the symbols involved. And again, you find a tie-in with philosophical ideas. So,
well, unfortunately, we have come to the end of our time with philosophical ideas, and that is terribly unfortunate. Richard, I've enjoyed your work so much. I enjoy reading the way you write, and I enjoy the material you have in your works. I want to congratulate you on extraordinary work, and I hope that in the future you can join us on our national show to discuss the mysteries of the sacred universe.